Okay, good morning everyone, and welcome to this week's CABE Webinar Wednesdays. This week's presentation is going to be on property protection and business resilience, automatic sprinklers, background and benefits. I'm Jack, I'm going to be moderating the webinar today, so I'll be taking your questions at the end. Don't forget you can ask questions through the questions tab in the webinar panel, and you will be able to catch up with this webinar on YouTube later. You'll be getting a link to that on social media, and also you can tweet about this with hashtag CABECPD. Okay, so today's presenter is Tom Roche. He's the Assistant Vice President at the British Sprinkler Association, and I'm sure he's got a lot of interesting things today. So I'm just gonna pass over to him. And
so good morning, everybody. I'm hoping you can see the screen.
It doesn't look like we can quite see your screen there yet, Tom. If you could just hit the in the sharing tab with the big play button. There we go. Excellent. Take it away.
Brilliant.
Thanks.
So good morning, everybody. So my name's Tom Roche. I'm from the Business Sprinkler Alliance, and today I'm going to talk about a bit of an intro to how sprinklers work, some of their benefits. Really sort of gives people a background into sort of regulation guidance and how that addresses the use of sprinklers, talk about the benefits of sprinklers, and then use an example from some offices to sort of understand some of the design considerations that could benefit from the incorporation of sprinklers, and then just offer a bit of a conclusion and then address any questions that may arise. For a lot of people, they may be asking, well, who are the Business Sprinkler Alliance? We're a group of 6 different organisations that came together in 2010, ranging from the National Fire Chiefs to the Fire Protection Association, BAFSA, the NFSN, EFSN, and an insurance company called FM Global, because we believed that there's a lot of discussion around sprinklers, but there was a gap in the marketplace where people were not discussing how sprinklers could benefit the industrial and commercial market. And that's where the Business Sprinkler Alliance came together, and it's been campaigning on that basis since. Used the word sprinkler a lot, so it would be right to start with the discussion with a little bit of background onto how do sprinklers work. It's still one of those areas where a lot of people nod and say they understand how they work. Just want to make sure we're all on the same page as we go through this. So a little bit of a brief introduction as to how sprinklers operate. Sprinkler systems are typified by similar things: a water supply, normally in the form of pumps and tanks for quite a lot of installations that we see here in the UK, although for domestic residential installations, that water supply may come in the form of public mains. So just a pipe coming in from the main in the road that comes into the building. A series of valves that are used to sort of control flow of water into the system. You may see some objects on the network of pipes, and these are to raise alarms, so either responding to pressure or flow. And then the business end, which are an array of sprinkler heads. And that's pretty much typifies a lot of the sprinkler systems that you would see out in the wild. A collection of pipes with pressurized water in them, sprinkler heads at one end, valves to sort of control flow, and the pressurized water coming from either the public mains or a pump and tank. The next element to talk about is really a sprinkler head. I know a lot of people have seen them, but just to sort of combat some of the myths, it's good to sort of go through the background as to how they work. The important parts of a sprinkler head really to talk about are two key objects. One is in all sprinkler heads you'll see a thermal element. A thermal element is the piece that actually makes the sprinkler head respond to fire. In modern sprinkler heads, that's typically a glass bulb filled with a liquid, and that liquid is sensitive to heat. That thermal element holds in place a plug, and the plug is there to hold back the pressurized water. So if the thermal element breaks for some reason, nothing will hold the plug in place and the water flows out. And that's the simple premise behind the sprinkler head. And to explain it a little bit further, if we think about a sprinkler head in a fire situation, the temperature at the ceiling will start to rise. The thermal element will start to respond to that. The liquid inside that bulb will start to expand. And as it does so, it gets to the point where it breaks that bulb. And then you start off the chain of events which sees the plug is ejected by the pressurized water, and then we get the water flow. The key thing to point out here, there are no wires attached to this. It's not about smoke. It's all to do with temperature and the heat that's generated from the fire that sets the sprinkler off. That's why all these stories you hear about people having a crafty cigarette or burning their toast, they will not set off a sprinkler system. And what you see in the movies where somebody presses one button and they all go off at once is complete rubbish. You'd need to individually go along and break all the different heads, like the thermal elements and all the heads to make them work for the basic sprinkler system. And the color of the liquid in the thermal element gives you an idea as to what temperature that sprinkler head goes off. In this example, the red liquid tells me this sprinkler head will respond to a temperature of 68 degrees C. So the temperature at that bulb has to get to 68 degrees C before it will break and the sprinkler will operate. And then any subsequent heads operating would also need to say the same temperature. Just to give you an idea of what a sprinkler head looks like in operation, here are some simple videos. Sadly, the video is not playing, but I'll explain these. In the top left on your screen, you can see just a standard head operating. And then in the bottom half of the picture, you'll see two different heads operating. These are what we would sort of refer to as storage heads. The difference between the two is the larger umbrella pattern. And in the picture on the bottom right, that's what we call an ESFR head. Again, a very large umbrella pattern, and you're also seeing a spike. If you look carefully at the picture, you'll see a white line dropping from the bottom of the sprinkler head. What that's signifying, is the pressure that you're seeing from that head. A suppression head is really there to knock down a fire. The other heads in this sort of picture are really there to control the fire. So to wet down the boxes or fire or the area that's under fire, to sort of contain the fire in that area. Now, this was supposed to be a very nice video, and here it goes, of a real-time fire situation. We've set this up in a lab, a rather large lab, to show the difference between fire in one situation with sprinklers and one without. These are just boxes of plastic cups in cardboard cartons, a very small storage array. It's a real-time fire. What you'll see, fire likes to grow vertically in storage arrays in particular, and you see the fire has got to the top of the array in under a minute. People should be surprised by that. Fire in this type of commodity can go very quickly. Now, just over the minute, you're seeing a sprinkler head operate to control one of the arrays. The array on the left-hand side of your picture has no sprinklers. So you're seeing quite a lot of water being deployed from one sprinkler head over the array on the right. That's starting to knock down the fire and control it. You're seeing some steam and some light smoke coming off that one. The image on the left, the fire is just continuing. And that fire will continue until somebody either applies water to it or that array runs out of fuel. The darkening effect you're getting is a combination of the smoke from the sprinkler fire, but a large contribution of smoke from the fire that's out of control. And this sort of indicates the difference that you'd observe in a sprinklered fire. Sprinklered fire would contain the fire, keep it small. The unsprinkled fire will just continue until either somebody intervenes or it runs out of fuel. People often ask about the cost of sprinklers. There's no hard and fast number to give people that sort of says every sprinkler installation will cost the same amount. There's differences depending on how you install sprinklers into a building. But just to sort of give some outline figures, if you were to pick up Spon's price book, you would see that an installed sprinkler costs about £180 per sprinkler head. A sprinkler water supply is in the range of £60,000 to £80,000. Now, I can tell you that for most sprinkler designs, each sprinkler head protects an area of roughly 10 square meters. And if you were to sort of look at a sprinkler installation for a typical warehouse in the 5,000 to 10,000 square meter range, the cost would even out to between £35 and £40 square meter installed for the water supply and the sprinkler heads and any valving arrangements. A topic that's been much in the news has been sprinklers in residential properties. Again, it's very hard to give a figure for each flat or each house is going to cost the same amount. Typical figures that we're seeing in the marketplace, placing a 2-bedroom flat in the range of between £2,500 and £3,000 to install sprinklers into. So that gives you an idea of the cost figures associated with sprinklers. I know some people have produced some sort of like information around cost, like some of the pricing agencies. So you can find this information quite readily, but it is very much project specific. Another area that people ask about is really regulations and how our current regulations respond to sprinkler guidance. In England, we typically see sprinklers are guided under element B3, internal fire spreading, which is the same you typically see around the world. If we look at the UK in particular, our country is quite complicated in the fact that we have devolved powers, and each region and country has slightly different application of their guidance, but there are some similarities that say there's a life safety focus when it comes to the use of sprinklers or the guidance for sprinklers. It's bounded by building use. What are we using the building for? The size of compartment, typically on area rather than volume, and then building height. And in terms of building height, it really refers to the story level or the height at which people will be within a building. And we typically sort of run into guidance for sprinklers in these different documents, whether it's approved document B in England and Wales, or it's the technical booklet E in Northern Ireland, or the technical handbook in Scotland. For those who have seen it, approved document B in England has been clarified, and a revised version or a clarified version comes into force on the 30th of August this year. That does include some clearer language around sprinklers, and in particular a new Appendix E referring to sprinklers. Just to take that a step further, we look at England. This is a table I often use to help people understand those three concepts of purpose group, compartment size, and height. Just to sort of talk you through this, in terms of a block of flats or an office in England, the guidance offers no compartment limit that triggers the use of sprinklers or guidance for sprinklers. However, when it comes to having a building with a story height above 30 meters, then that triggers guidance for sprinklers in those properties, so blocks of flats and offices. It's often confusing for a lot of people because they would see this the same as hotels, halls of residence, but there is no guidance for the use of sprinklers in regard to compartment sizes or story height in England. In terms of industrial and commercial buildings, warehouses with compartments larger than 20,000 square meters or a building higher than 18 meters would attract guidance for sprinklers in England. Now, to put that in context, that's the size of 3 football pitches or a 6-story building. And then comparing that to industrial buildings, there is no guidance. So if I were to build an industrial unit in the UK, I could build it of an unlimited size as long as I complied with the rest of approved document B in England. There is a gap, though, in people's understanding around regulations that comes up quite a lot. This is a piece of work that was done by the Business Sprinkler Alliance, where we had YouGov work with a number of SMEs to understand how they viewed building regulations and what it meant for their premises. And what's clear is that a lot of business owners feel that if they followed the building regulations, their premises would be adequately protected from fire events. The difference in our building regulations and their purpose to protect people and not property is not clearly understood. And that leads to some of the events we've seen recently where there is complete surprise and shock, where significant buildings burn completely to the ground, and people still call it a regulatory success because no one was injured. There's a complete disconnect and misunderstanding there, and something that perhaps we need to address. Another question that often comes up when it comes to regulations is, how does the UK compare to the rest of Europe? One area that you can compare them on is when you look at compartment sizes that attract guidance on sprinklers. It's quite clear that England and Wales have the largest compartment sizes that are allowed before guidance is given on the use of sprinklers at 20,000 square meters. Scotland is at 14,000 square meters, where surprisingly the rest of our nearest neighbours are somewhere at 5,000 square meters and below. It's an obvious area of disconnect and something that I believe will be scrutinised under the coming technical review of approved document B, because there is quite a disparity between those two numbers, and it does attract a lot of attention. Another concept that keeps coming up and we need to sort of think about is we're seeing a lot of discussion around fire being under control, and it's a comment that comes from looking at fire statistics. The trend is a good one in terms of we're seeing the overall number of fires year on year come down, which is a great thing. We're seeing the number of casualties also trend down with the number of fires. And this leads to sort of a situation where a lot of people believe fire is steadily under control. We all know, based on some of the reviews and consultations going on, there's a lot of concern that maybe we're missing some other trends in this. And there are certain instances that have caused a lot of people to sort of think again about where our regulatory guidance needs to go. I'd add to that by saying that actually we're seeing a counter trend. If you look from the cost of those fires in terms of material damage, the trend is going in completely the opposite direction. Since about 2011, we're seeing that cost of fire year on year grow, and it's growing quite significantly, and it can't be explained by a rise in cost of materials. We're seeing increased levels of damage for each fire, which is sort of counter to what we're sort of seeing from the number go down, but the cost is going up. So we're seeing a leveling in the overall cost of fire to people in general. And that's something that we need to sort of think very carefully about, closely about. So why do people like myself advocate the use of sprinklers? Because I do see a lot of benefits. There was a study done in 2017 based on fires across the UK and the data that's been recorded about those fires where we've seen sprinklers operating. And across 5 years, what they showed is sprinkler systems have a 94% operational reliability, which means 94 times out of 100 where they're called to operate, they operate effectively. 99% of the times when they're called to operate, they control or extinguish the fire. We also see situations where in 95% of those situations, 5 sprinkler heads or less operate to actually control the fire, and 65%, only 1 sprinkler head is operating. The thing I'd point to in these figures is really a case of these are real fire events. This is not a statistical exercise where somebody sat down to work out theoretical probabilities. These are real fire incidents. And what they go to show is this notion that all sprinklers go off at once is rubbish, because it's shown by the number of heads that operate in individual fires. And it also shows a high level of effectiveness. Hence why you see calls from the fire service that we should use more of these sprinklers in fire situations. At the same time, if we look at the financial impacts, and this is repeated around the globe, we're seeing figures that range from 10 to 7 times the size of fire. When we compare sprinkler to unsprinkled fires, the amount of damage that's caused is significantly less where sprinklers are installed. And this is why we see them as a huge benefit in property protection, and we see a number of businesses select to use them. So for building users, we see the benefits in the fact that sprinklers protect occupants. I know a lot of people think about sprinklers as a property protection device only, but time and time again, they prove their worth in terms of protecting occupants by giving them increased amount of time to escape. They do this by controlling the fire, as we've seen in the video, limiting fire damage, and for those operating a building, that means minimizing disruption. We often see properties that are involved in fires which sprinklers operate. The fire is quite small. They're able to return to business in a matter of days, as opposed to uncontrolled fire, which is quite significant. In terms of usable space, one of the things that we see repeated, and it's in our guidance, is the use of sprinklers allows the opportunity to increase compartment sizes. It does so because we're seeing reduced fire sizes. What this means for people is increased time to escape and means of escape. What this goes to show is where sprinklers are involved, there is a trend for the amount of usable space to be increased. In terms of fire resistance, we see the use of sprinklers being used to sort of balance the structural fire resistance in the building. This has an impact on compartment floors and ratings. It also has an impact on boundaries to buildings and positioning of boundaries for buildings, and the amount of unprotected area, as we would refer to it from the guidance. And sprinklers, because they reduce the size of the fire and the impact of fire, have an impact on all those areas. If you're able to use sprinklers to control the size of the fire, what this does is allow you to consider increased separation distances or reduce them. In terms of that, has an impact on boundary conditions, which we've seen have an impact on the available plot usage. Again, if you can place buildings closer together because they're adequately protected by sprinklers, we're not going to see the fire spread between the buildings, which means we can look at the boundary conditions, and that can mean increased use of the plot. One of the key areas that we see people use sprinklers for in terms of a benefit is freedoms, and by that I mean open spaces. Sprinklers are a key component of atria and the use of effective atria. They're used by a lot of people to sort of increase sight lines and exit distances. The increased compartment sizes are enjoyed by both commercial and industrial properties, where sprinklers offer the opportunity to have large compartment sizes and that open space feeling. And as we're seeing with residential properties, people want flexibility over how they use space, and sprinklers are a component of what we're now seeing as open plan living. Again, people want the freedom, but they need the fire protection. One of the ways to give that is to balance the use of passive and active and introduce sprinklers into buildings. So a total view of this is the combination of placing sprinklers into building offers opportunities. It's not just downside cost. It offers available sort of like protection for people and property. It offers flexibility. It offers that environmental view. If we can reduce the impact of fire, we're not emitting as much into the environment. And what that means is you can balance the cost of all those items. So sprinklers aren't just an additional cost, they offer additional benefits too. To put that into context, the Business Sprinkler Alliance did some work to look at how sprinklers could impact the design of offices. We did this work with an organization called WSP, and we asked them to look at, if we were to look at some standard office designs in different places in the UK and look at where sprinklers could be beneficial to that design, how would that look? What are some of the cost implications? This report is available for free on our website. You can download it. And basically it looks through those different aspects I've just described in terms of the benefits of sprinklers. And it looks at the capital costs of adding fire protection to a series of office designs. So just to sort of take you through some of the material from that, we looked at one example, it's a worked example of a building, rather large office complex in London with selected boundary conditions to understand what would be the impact of putting sprinklers into such a building. And from that, we worked out what the costs. So the upfront cost of putting sprinklers into that building was just over £300,000. But in terms of how that would impact things like boundary conditions and unprotected space, it had some startling impact in terms of overall costs. And what it showed is by putting sprinklers into the building, you could derive a saving somewhere close to £2 million or just under £3 million by the use of sprinklers in that property. So direct benefit from looking at the fire design, optimizing it with sprinklers, and the impact. Now, lest anybody think we're just loading the dice and using this example, we looked at other worked examples, and I've selected another one. This is for an office complex, a slightly smaller footprint, over 4 stories, something that would not naturally, require sprinklers, and looked at separation distances which were slightly healthier. There wasn't the need for as much fire-rated facade in this occupancy, or stair cores and exit distances. And we went through the worked example, and in this case, the numbers reverse slightly. The cost of sprinklers for this building were just under 100,000, but the overall impact in terms of the benefits that could be achieved between the trade-off in terms of facade costs, structural fire protection, what it would mean in terms of dry risers in the building, meant the cost differential wasn't the initial £100,000 for the sprinklers, but dropped to just a shade under 40,000. And what that was saying is really a case of, okay, sprinklers in this case, somebody could look at it as being not cost effective for this property, but the cost differential was not as significant as many people would think if you optimize the design with sprinklers. And that's the key thing that came out of this piece of work for us, is really to get people to understand that adding sprinklers has benefits, and that can be a monetary advantage in terms of the design, and that then transfers into life safety and also property protection. So you've got to think about the overall piece. There have been some fires that have attracted attention because of the scale of them. So I want to talk about a few examples in terms of some small case studies. The first one is an unusual one in terms of a car park. This was a multi-story car park in Liverpool. This happened, many people remember, the end of 2017, and it's a situation in which we saw a quite significant car park have a significant fire. This was the Liverpool car park. 1,600 cars were destroyed in this event. There was no fire protection in this building, and this is one of those fires that's caused people to stop and think, should there be protection? And the cost of this event is somewhere in the region of £70 million. It's caused a rethink in terms of the next car park that's going to be built to replace this in Liverpool, which is going to be fully sprinklered. But it's also having an impact on people thinking about the fact that in our guidance, such a structure would actually technically only need fire resistance of 15 minutes for a multi-story structure. It means it's normally of steel. There's a bit of a challenge there we need to understand, but real benefits could be accrued to something like this if, from a design point of view, by putting sprinklers in place. Not the most obvious thing that we sort of target, but it's one of those things that's becoming a growing issue as we start to see a number of properties built upon car parks. Another interesting one, although we have guidance for sprinkler protection into large uncompartmented spaces, this is a warehouse in Daventry. It's of the order of about 38,000 square meters, but it was designed and operated without sprinklers being included. And what we saw was the total destruction of this property within 6 months of it coming into operation. Small fire in the property spread, uncontrolled throughout. The fire service could not contain this fire, and it led to the destruction of the business. Although there was insurance involved, the company went into administration and was sold later in the year. Again, a situation where somebody had designed this building without sprinklers. Thankfully, everybody escaped and there were no injuries, but the property was completely lost. Again, this caused a number of people to stop and think, when we go above the guidance in the approved document, do we put in place enough measures to understand what that means in terms of resources that would be needed to fight such a fire, and what it means to go beyond the guidance? So this has been sort of quite a jog through sprinkler systems, going from how do they work, the basics of how the sprinkler head itself operates, looking at some of our regulatory guidance, a flow through into how some of that could be used in terms of benefits, and then looking at offices, and then just some case studies. So hopefully through this, I'm hoping that you can see that there's a real case here for showing that sprinklers are very effective, that sprinklers are not just for property protection, that sprinklers, although people will talk about the costs and reliability of them, they really do offer some opportunities. And if there's one thing that I think is coming more and more to the fore, is we're having to sort of look at layers of fire safety. Relying on one system alone is not enough, and we're going to see more of this going forward. And sprinklers are an important layer of safety. They offer benefits in both in terms of protection of people, but also protection of property. I know that latter point is something that people say shouldn't be in our guidance, but I think given some of the significant fires we've seen recently, we're going to see that change coming within the regulations soon. I hope you've enjoyed this session. I'm going to hand it back to Jack in terms of if there are any questions.
Thanks very much, Tom. So we do have a few questions in. So we have one from Graham here, and he's asking about if sprinkler systems ever activate accidentally, and are there any records kept of accidental activations?
Yes, in terms of accidental activations, in terms of sprinkler heads failing, it's a very, very rare occurrence. What we normally see from sprinklers misoperating, there's normally another actor. Either we've seen sprinkler heads attacked by cold weather, so they freeze, and then nobody knows they've frozen and they then subsequently leak. Or we've seen corrosion incidents that have happened to selected heads. But we're talking about something that, if we look at the number of heads that are installed in the world versus the number of occasions where we've seen those accidental leakages, we're talking in the millions to one. We're not talking about a situation where this happens on a regular occurrence. That doesn't mean you can abuse the sprinkler system. You do need to install it correctly, you do need to sort of test it, and you do need to maintain it. But the notion of accidental release of water, they're very rare events, and we're talking in that millions to one.
Okay, so next up we have a question from Chris, who says, thank you for the great presentation, and then asks, for what purpose in property protection would you use different thermal ratings of sprinklers?
Basically, we use different thermal ratings because there might be different temperature gradients across a building. The simplest way to explain this is I use my local Tesco store. My Tesco store has sprinklers throughout, but then when I get to the bakery area, obviously the ambient temperature around the bakery is higher. So basically what I would do there is I would probably have some sort of barrier at the ceiling, and I would use a different temperature rating for the sprinkler head. I'd still want the sprinklers to be above the bakery, but recognizing the ambient temperature would be higher, I'd want a different rating for the bulb. So I'd probably want a blue bulb in there. The temperature rating would be 140 degrees C. But in the rest of the store, where it's a normal temperature, they would return to 68 degrees C. So it would depend on what the temperature in that area. So at Tesco store, the bakery, let's have a higher temperature rated head. In the rest of the building, I would use a lower rated head.
Okay. So, now we have a question from Colleen, and she asks, how are sprinklers maintained and how often is advisable?
Okay, so in terms of sprinkler maintenance, in terms of the head itself doesn't really need any maintenance. It really comes down to things like fire pumps and valves. Now, in industrial settings, fire pumps, if you've got a diesel engine, it needs running each week, and that can be run by somebody for half an hour. If it's an electric pump, it might need to be turned over for 15 minutes. Valves themselves, once a quarter, so every 3 months, you probably need to make sure the valves are manipulated. And so across the year, you'd probably be on a regime where you're testing different parts of the sprinkler system on a different regime. In terms of an overhaul of things like the alarm valves themselves, you probably want to get them looked at once a year by a specialist who come in and probably strip down the valve and just make sure it turns over and it operates in the way it should. So there is guidance from a number of areas, including you can find a lot of this guidance in the European standard, which will give you a regime that says how often you need to test this or parts of the system. But the heads themselves, a lot of people ask, do we need to do anything with the heads? No. Sprinkler heads, we suggest every 25 years you remove a sample of the sprinkler heads and you check them for operation. Visually, in terms of checking them, it's really a case has anybody painted them. It really comes down to the parts and the components that turn over and move. So that would be pumps and valves that need to be checked.
Okay, so now we have a question from Jane, and she asks, is there any design of sprinkler on the market that will protect against the spread of fire across the external facade on a building?
Okay, typically we see sprinklers used on the facade of buildings as what I would call boundary protection, and typically that's done by using open sprinkler heads, or what are called drenchers. So you arrange a series of heads that poke out through the wall of a building with heads that play down the side of the building, and they're open. And then they're either triggered manually, or they're triggered by some sort of other technology to sort of set them all off at once, and they all go off at once to protect like windows or a wall. They're really the only things that I've ever seen, and they're typically done for boundary protection, i.e. we've got two buildings too close together and to stop a spread of fire between them. In certain areas of London, if you take a walk through the city and look at certain offices, you may see these heads because London's an area where we've seen them too close together. In terms of a sprinkler system that will overcome poor construction, I'm going to say no, that's not a way to go. That's not a good thing. We don't see a sprinkler system being the way to defeat poor or combustible construction on the face of a building. It's more to protect spread between buildings. Hoping that helps.
Okay, so we've had a couple of questions about water mist systems as well, and Steve says he's very pleased to have seen your CPD this morning, and does your organisation equally support water mist systems as well, and what are the benefits of these compared to normal sprinklers?
Okay, so water mist is a fantastic technology, and I will call it an adolescent technology in terms of how our understanding of it and how much it's been used. The thing to sort of say for people when they look at water mist versus sprinklers is that sprinklers are about wetting down the surface of combustible material to sort of stop the spread of fire. Water mist is actually interacting with the surface fire spread to disrupt the fire. They operate in slightly different ways, and what that means is the range of applications for water mist is narrower than sprinklers. And at the same time, so what that means is, in terms of industrial settings, the use of water mist to protect, say, a warehouse is not the way to go. If it was an enclosed space or a smaller space with some combustibles in it, that will operate. So the technologies are slightly different, and they're at different steps in their development and understanding. Water mist is a very good technology. We're seeing a lot of it being used in residential and light office spaces, and that's a great use of it. The challenge is we don't see the same level of certification for products and understanding of the performance over time of those products. So sprinkler heads have been around for a long period of time. So when it comes to sprinkler heads, they're very standardized and very interchangeable. Water mist technology and nozzles are very bespoke. And once you select a solution, you're tied into that solution. You can't swap nozzles or systems quickly. And that's the key differences. So it's a great technology, narrow application, not the same level of understanding of how it performs with all occupancies, and the level of, if you like, interchangeability of the systems is lower. So if anybody was looking to use a water mist system, they need to check some of those things carefully in terms of, is this water mist system being tested for the application I'm trying to use it in, of not going beyond the boundaries? Has it been proven to work in that? Do I understand the technology that's being specified, and will it be around for a period of time, and is it maintainable? And then, you know, who's installing it, and do they have the credentials to install this correctly? I've jumped around that a little bit, but hopefully that gives you a flavor for, yes, support water mist, but do so carefully at this stage.
Okay, so now we have a question from James, and he asks, what is the average economic life of a sprinkler system, and what would be the average cost of maintenance of a typical sprinkler system over its economic life? Although I'd imagine that would depend a lot on the size of the solution.
So typically, a sprinkler system will have the same economic life as a building, so 25 to 30 years. The oldest sprinkler I've ever retrieved from a building in the UK was dated 1903. And that came out of a paper mill in Scotland, and we sent that for testing, and it still operated effectively. But naturally, we're not expecting sprinkler systems to last hundreds of years. Operational life is normally life of building. Cost of maintenance depends on the size and complexity of the system. So typically you're looking at something, if you had a bog standard warehouse with a couple of valve sets, a pump and tank, you could be looking at the order of about £1,500 a year to get a specialist in to maintain that in terms of that cost. But there will be additional cost in terms of somebody's time to regularly run the pump and look over the system, which a lot of people say is, you know, it's comparable to other systems within a building that you would need to maintain over their life. I'm hoping that gives you the answer you're looking for.
Okay, so we have a question from Martin now, and he's asking, can sprinklers be fed from mains water supply, or is a large tank always required?
It very much depends on the water supply. I've got to be brutally honest in saying in the UK, we are not blessed with the most fantastic public water network. In some areas, you can see supply from the domestic mains work, but this would normally be for residential and light office areas. You would not see enough water mains pressure to supply something like a warehouse, just based on the volume of water that's required and the pressure needed. So at that lower hazard end, there's an opportunity to use the mains water supply. As the hazard increases, you're more into the range of a pump and tank. And that mirrors what we see in the marketplace today, where residential, domestic, a lot of times it's about mains or even mains plus a small pump. And then when we get into industrial or commercial, it's more pump and tank.
Okay, and now we have Jen again, and she's asking about retrofitting of sprinklers. Would that be possible?
Yes, retrofitting is possible, but like everything that ever retrofitted into a building, costs escalate. And the cost escalation is normally a matter of access. So personally, across my career, I've helped a number of clients retrofit sprinklers into a building. The cost is not in the material, it's in how clever you are to sort of get access to the roof to install them and then to sort of connect them together. And access cost, normally at height, can be the determining factor in terms of how expensive it is. In terms of retrofitting sprinklers into offices and residential, again, eminently possible because of lower ceiling heights. The challenge is often coordinating where you put the water supply and how you connect to that water supply. In commercial property, because of the arrangement we normally have with service ducts and voids, that can make life a lot easier. In residential properties, we don't generally do that sort of thing, so gaining access to voids in areas to run pipes becomes more difficult. But retrofit is possible, it's just the additional cost comes because of access to areas and the messing, and for want of a better term, the messing around to actually achieve it.
Okay, so now we have Graham again, and he's asking about the system needing to be drained down for maintenance, or is the maintenance carried out with the system charged up?
In terms of maintenance, routine maintenance is normally conducted with the system full of water. There's no requirement to drain it down. In terms of flowing a pump, you can normally do that and test it without having to sort of do anything to sort of like the rest of the system. In terms of checking whether a valve operates or turns, you don't have to drain down the system. It's normally if you have to open something like the valve set once a year, that can lead to a situation where you need to drain down the system to do that. There are ways of arranging bypasses to keep all the systems live, and that's sometimes what you see in what we call enhanced reliability systems, where you can arrange bypasses so that you can open a valve and look at it without having to drain down the system. Typically, when we're thinking about sprinkler systems, we don't really want to impair them, i.e. switch them off, if we can avoid that. We don't want to drain down the systems because obviously we're removing that level of protection. So we minimize that as much as possible.
Okay, I'm just going to check to see if there's any more questions. Okay, so we have a question from Nick here, who asks where residential sprinklers are installed in order to show compliance with the building regulations. And these are fed from the main supply. What measures will be in place to counteract possible interruptions with the water supply?
In terms of residential properties, there are two ways in which we see them installed. Either there's a direct feed from the mains, or we see what we'd call like a buffer of water held in a tank and a small pump. In the latter example, that buffer gives you time should there be interruption to the main. Otherwise, if there is an interruption main, that would remove your sprinkler protection. Now, that is a rare event, but it is one where if that happens, a person with such a property needs to be aware the sprinkler system is off because the mains have been shut down. But my experience of the mains going off is incredibly rare because of the needs of the public. Water companies normally move hell and earth to keep that water supply on.
Okay, so I think we're all done with the questions there. I'm not seeing any new ones come in. So I guess all there is left to say is thanks very much to Tom.
Thank you very much. Sorry for running through that quite quickly, but I'm sure if there are any more questions, I'm sure you'll quite happily receive them, and you can pass them on, and I'll try and answer them.
Okay, I will do. So like I say, you will be able to catch up with this on YouTube later on, and you'll be receiving an email in about an hour with a link to the next CABE webinar Wednesdays, which is on fire risk assessment and PAS 7.9. Okay, thanks everyone for watching, and hopefully we'll see you again next time. Thanks.